if you are from a country around USA, Europe, or Australia. You might notice some beautiful and also strange auroras visible in the sky. Well, they might look beautiful, but if you saw a red auroras in the sky, did you know that it is a predication of one of the dangerous things that we are going to suffer? Well, according to the data from the current predictions, our sun is approaching to a peak of its solar activity. And the strange thing is, this might be worse than the Halloween storms of 2003, which caused huge technical glitches. Okay, so if we break our video into the facts, we are going to discuss about what caused this solar activity, what is a solar cycle, what are geomagnetic storms, historical relation of this, and the danger of such solar activities to our daily lives. Then, let's dive into our first topic. So, if someone asked what is the reason for the solar activity which had affected the Earth, the answer is solar cycle. Okay, from the start of current technological researching, the scientists who study about this incident has found a pattern of 11 years. This pattern was identified by using the sunspots that some of them are visible even from Earth. A sunspot is a place on the sun's surface which has comparatively low temperature than its surrounding. These places are usually having a dark color. Well, according to the data from the researches, when the sun is approaching to a high solar activity, there are more sunspots in the sun. And these sunspots releases solar flares into the space. And sometimes there might be solar flares which are ejecting directly towards Earth. And when the magnetosphere of Earth protects us from these dangerous solar flares, the interacted particles of the sun in our atmosphere create stunning displays of auroras. Okay, we discussed about what happens when our sun is in its highest activity period, and it is known as a solar maximum. And when the sun reaches its least activity period or solar minimum, number of sunspots is also minimum or sometimes zero. Well, the major reason for this solar cycle is the polar magnetic reversals of the sun. Actually, most of the scientists believe that the magnetic field of our sun is generated by the inside of our sun by the movement of the plasma inside its interior. And this process was named as solar dynamo. As a result of this, the magnetic field of the sun changes and the North Pole becomes south and South Pole becomes north. This is known as the polar magnetic reversal of the sun, and this is happening at the middle of the 11-year solar cycle. According to the scientists, the polar magnetic reversals of the sun happens in a cyclic process. So, to complete a full cycle, it takes 22 years. Then, let's talk about what are solar flares and geomagnetic storms. Solar flares are intense bursts of radiation emanating from the release of magnetic energy associated with sunspots. They are the solar system's most powerful explosions, capable of emitting as much energy as billions of hydrogen bombs. These solar flares can emit all the way from radio waves to gamma rays in the electromagnetic spectrum. There are 5 main types of classification of solar flares. They are A-type, B-type, C-type, M-type, and X-type. The A-type is the weakest, and it does not cause any significant impact towards the Earth. The B-type is also not enough to cause any significant damages to our atmosphere or technology system. If we go into the C-type, this type of solar stars can do a minor damage towards our Earth. Sometimes these king of storms might cause small radio blackouts in the polar regions. But these kind of storms are also not enough to cause any significant disruption. Okay, if we turn into the M-type, this might cause radio blackouts at the higher altitude and minor radiation storms that might affect astronauts and satellites. X-class solar flares is the most intense, and these X-class flares can cause widespread radio blackouts, long-lasting radiation storms, and significant geomagnetic storms that can disrupt satellites, power grids, and communications systems. If you see here, these solar storms are further classified from 1 to 9 in order to represent the intensity of these solar storms in each class. For example, an X3 flare is 3 times more powerful than an X1 flare, but less powerful than an X4 flare. Here is a summary of solar flare classification. A and B class, these flares usually have no noticeable impact on Earth. C-class can cause minor disturbances in the ionosphere, potentially affecting radio communications. M-class, more significant impact, including brief radio blackouts and minor satellite disruptions. X-class can cause severe space weather events, leading to extensive radio blackouts, GPS signal degradation, and geomagnetic storms that can affect power grids and communication systems. So, let's understand what is a geomagnetic storm and coronal mass ejection. Geomagnetic storms are disturbances in Earth's magnetosphere caused by the interaction between the solar wind and Earth's magnetic field. Coronal mass ejections, CMEs, are massive bursts of solar wind and magnetic fields rising above the solar corona or being released into space. Okay, so let's learn about the beautiful auroras and how they are formed. There are 4 types of auroras. They are green auroras, blue and purple type auroras, yellow and pink auroras, and red auroras. Green is the most common color, typically produced by oxygen molecules located about 60 miles above the Earth. This green light results from oxygen atoms colliding with solar particles at higher altitudes. Red auroras are less common and usually occur at higher altitudes. These are produced by high-altitude oxygen atoms that emit red light when they are excited by energetic solar particles. Blue and purple auroras occur at lower altitudes and are produced by nitrogen molecules. When solar particles collide with nitrogen, they emit blue or purple light. Yellow and pink auroras are a combination of the red, green, and blue emissions. They are less common and often seen where multiple altitudes and gas types interact. These solar storms can cause disruption of communication systems, affecting communication systems used in aviation, maritime, and emergency services. The radiation from solar flares can interfere with satellite communications, leading to disrupted phone calls, internet, and GPS services. Solar activity can also induce currents in power lines, potentially leading to voltage instability and transformer damage. Increased solar radiation and charged particles can damage satellite electronics, affect their orbits, and reduce their operational lifespan. This can lead to the loss of critical satellite services, including weather forecasting, navigation, and communications. High-energy particles from solar flares pose serious health risks to astronauts and airline crew, especially those flying at high latitudes and altitudes. Increased radiation exposure can lead to acute radiation sickness, increased cancer risk, and potential harm to the nervous system. Remember, your support helps us bring more exciting space content to you. So, like, subscribe, and share this video with your fellow space explorers. Stay curious and keep looking up.